So managing weeds, question is what are the key challenges we're looking at the moment? I think one of the key challenges is definitely legislation, which is removing actives from our toolbox. All the EU legislation, Water Framework Directive, endocrine disruption, hazard criteria, it's all removing the number of actives we've got available in terms of herbicides to control weeds. We've got growing resistance to some weeds to herbicides, and that's becoming an increasing problem. And those of you that were awake this morning will see there's a certain amount of familiarity to this slide, and that continues because we have slowing arrival of new active herbicides onto the market. And all that means that we possibly have a situation where weeds are out of control. Certainly driving up and down the A14 this summer, looking out the window, I think certainly some farmers have lost control of their weed problem. So that's basically the same slide that I showed this morning in terms of fungicides and fungicide resistance, and it's a very similar problem in some respects. But there are some important differences between weeds and pathogens and weeds. We've got an awful lot more target species in weeds than we have in pathogens, certainly in cereal and oilseed pathogens, which makes your job a lot more complicated. As I've already said, we've had no new mode of action. We've had no new mode of action in herbicides for 20 years. And if you talk to the agrochemical companies, we're not going to get another one in the next 20 years. We've got to deal with what we've got, and what we've got is getting less all the time. Cultural control is important in weed control. There's not much you can do in terms of cultural control for disease, apart from grow a resistant variety and change your sowing date, but it's very important for weed control. Weeds are good. To some people they are. If you talk to the RSPB or certain NGOs, they'll say, oh yeah, weeds are brilliant, they're good for biodiversity, help the insects and all that sort of thing. I don't think anyone's going to be out there waving the flag for yellow rust saying it's important for biodiversity. Spread of resistance in weeds is by gene flow and seed flow. In terms of pathogens, we're basically talking about gene flow, but seed flow is quite important. If you talk to farmers in Scotland and Wales, they'll say that resistant blackgrass is arriving on the back of lorries, and that's something that needs addressing, I think. And importantly, every field is different. Every field has got a different weed burden, different weed species, and different levels of resistance, which makes your job a lot more complicated than it does perhaps for pathogens, where you're dealing with septoria, yellow rust, and it's basically the same across the country, and you can treat it the same across the country. So there it is, blackgrass, our beautiful blackgrass that's all become all our familiar friend. This picture was taken just down the road in Brampton at the the Hutchinson's blackgrass research site. But of course, everyone's got their own blackgrass research site now. We've got NIAB a little bit further south. Agri have indeed got one down in Essex. Everyone's got, all the ag chems have got theirs, because blackgrass is the weed that's killing arable farming in the east of England. And this particular field was cut for silage about a week after this picture was taken. Cut for silage, of course, after the farmer had put his establishment costs in, its herbicides, its fungicides, its fertilisers, and then he cuts it for silage. It's a big, big loss, as you don't need me to tell you. So, I'm sure you already know this, but why is blackgrass such a problem? Well, it germinates in September and October, just when we've produced a nice seed bed for it. If you're talking about oilseed rape, you probably put a little bit of nitrogen on there as well, just to help it along. We've got a high seed production rate. A single blackgrass head can contain 100 seeds, and a big blackgrass plant can contain 10 heads. So a single seed germinating blackgrass can create 1,000 seeds going back into the seed bank at the end of the year. So a small problem could become a very bad problem very quickly. And I think that's what we've seen in a lot of places in recent years. It's a difficult herbicide target. If you go onto the Bayer website now, you'll see that they tell you Atlantis, hit it in the autumn. You're almost wasting your time in the spring. They don't perhaps put it quite like that. But you need to hit blackgrass early with your post stems, but it's a difficult target. There's two small leaves poking up. They're very small. They're not an easy target to hit. And of course, it's competitive with wheat. You don't need many blackgrass plants in there reaching maturity to start having an impact on yields.
Sorry, you just an interesting point. You just said Atlantis post-emergence in the autumn is much better than the spring. Do you agree with that?
If Bayer are saying it, I'm quite happy to go with what Bayer say. And I would, a blackgrass plant in the spring, which is larger and growing actively, is going to be more difficult to kill if it's got any degree of herbicide resistance than a small blackgrass plant that's growing actively in the autumn. That's my personal opinion. So is this blackgrass menace new? Well, this is a picture taken out of a book that sits on my shelf. I used to collect old textbooks for reasons I won't go into. Agricultural Botany, Theory and Practical, 1936 edition. Blackgrass is a troublesome pest on arable ground, blah, blah, blah. It's not new. It's been around since the year dot, probably. But it's become a really, really bad problem. And the reason it's become a really bad problem is its resistance to many herbicides. It's particularly resistant. I mean, 10 years ago, you'd just gone out with your Atlantis in the autumn or in the spring, sprayed it, job done, no problem. But some people say now that in certain situations, all that Atlantis does is greens the blackgrass up because it's become so resistant in certain situations. Still works well in others. Huge variation from field to field. In terms of spread of resistance, this is quite old data now, 2010, comes from Rothamsted. I don't know what's happened here. There should be a little dot about there. But basically, first resistance was found in Oxfordshire in 1982, but the first serious resistance to herbicides was found in blackgrass in Essex in 1984. And now we've got to a situation, or we had in 2010, more than 16,000 farms in 34 countries. And now we have confirmed, I believe, instances of blackgrass resistance, herbicide resistance in Scotland, and even reports in Wales. It's just getting worse and worse. And I think it's fairly widely accepted now that on any farm that's been using blackgrass active herbicides, where blackgrass is present over the last 25 years, has some degree of resistance to herbicides. Looking at it another way, this is a Bayer slide. This is, it's not a random sample, this is samples that were sent in for testing between 2006 and 2010. And the red dots, of which there are lots, is target site resistance to herbicides. The yellow dots are enhanced metabolism. And the green dots, and there are a couple, there's one there and there's a couple there, are susceptible. So people that were sending in samples thinking they were resistant were resistant. If you think you've got resistant blackgrass, you almost certainly have got resistant blackgrass. It's everywhere. So what, as far as we know, is the status of resistance? Well, our saving grace at the moment is that glyphosate resistance is not known in blackgrass. As far as we know, there is not one single instance in the UK of blackgrass being resistant to glyphosate. And that's our saving grace at the moment.
Could it happen?
It can, I'll come back to that. The basis of our blackgrass blackgrass control, really now, we're leaning quite heavily on the pre-emergence, flufenicets, pendimethalin, etc. We know there is resistance developing to these. If you take susceptible blackgrass, grow it in the glass house over several generations and expose it to these herbicides, you will start to get a build-up of resistance. It's not complete, and it seems to be, in the field, seems to be developing quite slowly. But there are places now where these aren't working as well as we'd expect them to be. This is our real problem, our post-stems, our ALS and HGCA inhibitors. Resistance is now widespread. Oilseed rape herbicides, carbetamide and provisamide, no known resistance, but we're almost certainly going to lose those, at least in parts of the country, to Water Framework Directive in the next few years.
You still have to capture the plant when it's small enough, isn't it?
Yes. But they do work, and as far as we go, again, there's no evidence of resistance. But at least in some water catchments, we're probably going to lose those to Water Framework Directive over the next few years. Hopefully not over the whole country, but it's a possibility. Other herbicide-resistant grass weeds. Second most important in the UK. Anyone? Go on. I'm sure you all know. Okay, you're all being very shy. ryegrass. Target site resistance to all the HGCAs has now been demonstrated. And ALS resistance in ryegrass was first confirmed in the UK in 2012. Enhanced metabolism is also common now in ryegrass. How common a problem is it? Well, it was first identified in the UK in 1990. 8 years later, we had over 100 cases in 21 counties. By 2010, that had risen to more than 300. In the last 4 years, it's gone up by 50% again, and we're up to over 30 counties. Resistance is now widespread to herbicides in ryegrass, and it's a serious problem in Europe. Parts of Europe, this is a real big problem. It has the potential to be worse than blackgrass, you'll be pleased to know. It's more competitive with wheat than blackgrass, and it has the potential to produce more seeds than blackgrass. At the moment, this is still a relatively limited problem, but it has the potential to be a real problem. And if that wasn't bad enough, in 2014, this paper was published in the scientific literature. In Italy, they now have ryegrass, which is resistant to HGCAs, ALS, and glyphosate. There's no reason why we can't get glyphosate resistant, as far as the biology is concerned, there's no reason why we can't get glyphosate resistant blackgrass. At some point we'll probably get glyphosate resistant ryegrass. I'll leave you with that nightmare scenario. After ryegrass, as you're also shy, I'll have to tell you, next most important herbicide resistant grass in the UK is wild oats. Wild oats is a slightly different prospect to blackgrass and ryegrass. So far, resistance to the HGCAs is being isolated to the FOPs, so some of those will still work quite well. And so far there's no resistance to ALS inhibitors, but enhanced metabolism has been found in wild oats. It's not quite as common as ryegrass. First identified in '93. By 2014, we're up to about 250 cases. But over the last 4 years, it hasn't actually gone up very much. And we know why that is. I say it's not yet a serious problem in the UK. It tends to occur in patches. And the reason it tends to occur in patches is because wild oats are self-pollinating. So pollen from resistant oat plant won't go across the field and pollinate an oat plant on the other side and make that resistant. It's self-pollinating, so the spread of resistance in wild oats is almost entirely by seed spread. So if you can stop the seed spreading around, and it's relatively easy with wild oats, you can contain the resistance, you can treat it in patches. But don't let that make you complacent, because if you go to Alberta in Canada, 28% of the fields in Alberta have herbicide-resistant wild oats. It's not a problem now, it's a problem we should be able to deal with fairly easily, but we need to realise it's out there and deal with it before it becomes more of a problem. So if herbicide-resistant grass weeds weren't enough, we've now got herbicide-resistant broadleaf weeds in the UK. We have ALS-resistant poppy, and these are ALS-resistant poppies not too far from here, north of Cambridge. And they are a significant problem, particularly in Spain, but also in Italy. Spain has real problems with herbicide-resistant poppies. The other two we have in this country are mayweed and chickweed. And they're still fairly small-scale problems. Chickweed resistance was first identified, this is just to ALS we're talking about now, in 2000. By 2014, we had more than 40 cases in 13 counties. It's mainly a problem in the north of in Scotland and Northern Ireland, so not really a problem in this part of the world. And there's a single mutation, so-called proline 197. It's got nothing to do with the fungicide proline, but this, because it's just got this one mutation, it means that some of the ALS herbicides still have some activity on chickweed. Poppy, first identified in 2001. We now have more than 25 cases in 9 counties. It's an increasing problem. And there are 2 mutations in poppy, the proline 197 and the tryptophan 574 mutations. Because it has those 2 mutations, or in a lot of the populations have both of them, really none of the ALS work anymore on those. And mayweed has emerged. It's still a small problem. All of these really aren't massive problems unless you happen to have them on your farm. but we need to be aware that they're out there. Is it going to get any better? Well, the answer, I'm afraid, is no. This is a slide taken from quite a good website, weedscience.org, and this shows the number of species globally. This is global data which are resistant to herbicides and different herbicide classes. So here's your ALS resistance, and it's the one that's going up most rapidly, and there are biological reasons for that, that ALS herbicides are the ones most likely to develop resistance to. Unfortunately, ALS herbicides are also the ones that are regarded as most environmentally friendly. So when we lose everything else, or when we lose a lot of other herbicides, the ALS ones are the ones we like to be left with, and they're the ones most likely for resistance to develop into. But all these lines are going in the same direction. Herbicide resistance isn't going away. So that's the problem. What's HGCA doing about it? Routine herbicide trials, for a start, no, we don't do them. We never have, and I don't think we ever will. The reasons, there's no new mode of action. Everything that's been out there has been out there for at least 20 years. Everyone pretty much knows how it works. There's not really an awful lot of point as trialling herbicides next to one another, because lots of people are doing these sort of trials, distributors, ag chem companies. If you want to know which herbicides work best, there's plenty of places you can go around the country and see this. There's no point in us spending penny money duplicating what other people are doing. There's also the fact that every field is different. So you could go look at this trial here and see that perhaps this particular product happens to work, or this combination of products works best, and go try in a different field where your blackgrass in this case has a different resistance profile, and another herbicide combination will work better. It's not like with septoria or yellow rust or brown rust, where pretty much everything works the same across the country. Every field is different. So we've tended to focus on alternatives to herbicides. Recent things we've looked at, inter-row spraying, this kind of contraption where you've got, you spray glyphosate down these shielded covers, and your row crop, sugar beet or oilseed rape, is in the middle, protected from your glyphosate. But obviously, going up and down the field with this kind of thing, it takes rather a lot of time. But perhaps we'll see more of these in the future as our herbicide options become fewer and fewer. Sowing date, seed rate, cover crops, all the sort of things you'd expect us maybe to look at. Competitive cultivars, broadleaf weeds, and blackgrass ecology, which you may think all sounds very woolly and lovely. But I hope I'll show you later on that this is something we need to look at because other options have failed. So this is our cultural control options for blackgrass, and this is some of this work's been funded by HGCA, but most of this has been funded by other people. We're looking at a lot of experiments here. This is a summary that was done by researchers at Rothamsted. They looked at all the experiments they could find, look at these different ways of controlling blackgrass. And you can see all of these work. You can give you some control of blackgrass. The problem with cultural control options, of course, if you look here at ploughing, it can actually make the situation worse. You can give you 95% control, or it can make the situation 82% worse. Similarly, delayed drilling. Obviously, if you delay drilling, but unfortunately you end up in drilling into a weather window where your crop doesn't establish very well, so it isn't very competitive, it can make the situation worse. You need to get these cultural control options aren't easy options. Some of the other ones, such as spring cropping, higher seed rates, competitive cultivars, tend to only go in one direction, but they're not easy things to do necessarily. The most effective by far is spring cropping, and this is a series of experiments summarised comparing wheat sown mid to late September with a spring crop, and these are a number of blackgrass plants per square metre. You can see in all cases we've got a big reduction, as you'd expect, with an average reduction of 90%. I mean, we're still talking about a lot of blackgrass plants, in some of these cases 300 plants per square metre, but compared to 6,000 per square metre, we're talking about big numbers now. We're dealing with an imperfect situation, but we have to drive it in this direction, and eventually we'll get down to a situation where we can manage it, hopefully, well. Of course, delayed drilling and spring cropping aren't easy options for the grower. There are costs involved. And I think one failing we've had with our research, perhaps in terms of looking at cultural control for blackgrass, is not putting numbers on it in terms of cash value in the past. This is one experiment where they did look at actual cash values, an experiment done by NAOAB, comparing winter wheat and spring wheat. September sown, early and late October sown with spring sown, and perhaps as you'd expect of the winter sown, the early September did better than the late October, although they actually, in this case, this one trial, the early October sown trial yielded the best, or crop yielded the best. But actually, in terms of gross output, the spring crop yield had the best gross output, and the September sown had the worst gross output. I mean, this is just one trial in 1 year. But spring cropping doesn't necessarily mean lower gross output. Why did the September one do so badly? Well, obviously, you've got more blackgrass in September. But remember also, if you go with an early crop, as Simon mentioned earlier, you've got potentially more pests and diseases. If you went with an early sown crop in autumn 2013, you almost certainly, if you had a variety without a 9 rating, you almost certainly ended up with yellow rust in it, and almost certainly probably ended up with brown rust in it. So you'd have had to go in with certainly a T0 and maybe a T-1 to control that rust. So you're potentially putting yourself into more expense by going that route. So don't just consider yield, it's how you get that yield, how much it costs you to get that yield with that earlier sown crop. But as I've already said, it's not an easy option for growers going for late drilling or spring sowing, particularly in this part of the world on heavy soils. It's a gamble, there's no doubt about it. But I'd say the easy solutions to blackgrass have gone. There are no easy solutions, and maybe sometimes you have to gamble. If you've got 6,000 plants per square metre, you can't. If you've got 600 plants, but if you've got 100 plants per square metre, you can't carry on the way you're going. You have to change something. As I say, the easy solutions are gone now. What are we doing at the moment? Quickly back to ALS-resistant broadleaf weeds. We're focusing on poppies as a model species. The biology of all of them, all the ones we've got in the UK, is the same, so we're just using poppy, mainly because it's got big seeds that are easy to work with. You try working with chickweed seeds. You can barely see them. Oh, sorry. Raising awareness is an important part of this project. I've already said they're not widespread, but the potential is for them to become more of a significant issue. We're also looking at how fast resistance develops. If you do something really stupid, like just go out and use ALS herbicides on their own against a field with poppies in, how fast will you develop resistance? And also doing a little bit of work looking at herbicides. So this is the Cambridgeshire trial site where they've got ALS-resistant poppies in July 2013. That's our untreated. And they're just using ALS herbicides. And there's not really a lot of difference between the untreated and the ALS only. But if you go with a non-ALS, there are odd poppies in there, but basically you can still get good control. In the case of poppy, pendimethalin works pretty well. And this is that same trial we just looked at the photo of. So here's your untreated, here's your ALS alone, practically no difference. But when you put a non-ALS or an ALS plus a non-ALS, and you get pretty good control. We can still control these things at the moment. But we're going to lose more and more herbicides. And as I said earlier, the ALS are the ones which are least environmentally damaging, so they're the ones that we're going to become more and more reliant upon. So this has the potential to become much more of a problem. We need to be aware that it's out there. Project we call added value fallows, but actually it's really about cover crops. We know that fallowing now is being used increasingly by growers to control blackgrass in situations where nothing else has worked. So the question is, rather than just leaving a field fallow and going in and cultivating it and killing blackgrass with glyphosate or cultivations, can you get added benefit from that fallow by growing a cover crop instead? Can you get better weed control, improve soil structure and fertility, and some biodiversity benefits? Well, this project's had 2 years of its 3 years, and so far I have to say the results aren't looking particularly promising. Over winter fallows, over into cover crops, sown in sort of August-ish time and removed in March before spring crops, seem to have fairly limited use in these trials. Where we've tried to use legumes, they're slow to establish, and that means they don't really fix any nitrogen. And the cover crops are destroyed in the spring for a spring crop before they flower, so you've got very limited biodiversity benefits. In fact, this particular project shows that actually an overwinter cover crop may be detrimental to your blackgrass control because it removes the opportunity to go in and spray over and over again with glyphosate. It's possible if you use a larger cedar crop such as vetch and black oats, you might get more of a benefit because they'll establish quicker than some of your smaller seeded clovers and other crop things, but costs are going to be higher. So it's not looking brilliant for this. We've also looked at 12-month cover established in autumn, but again, that doesn't look like it can compensate for that lost ability to cultivate and spray off with glyphosate in the autumn to control your blackgrass, despite the fact that it was mowed repeatedly. From this work, it looks like the best thing you can do in terms of cover crops is do your autumn cultivations, your spraying off with glyphosate, kill as much blackgrass as you can, and then if you're going to go for 12 months, do a spring establishment, because that's when your cover crop will get away well. You'll get your biodiversity benefits over the summer. You'll get your nitrogen fixation. You'll get your organic matter that's ploughed back in the autumn, and put in an autumn crop. That looks like it's the best option from this project. Although I know there are other people out there saying different things for cover crops. And this is a cover crop that was established in April this year. A species mixture and a straight white clover. Something else we're looking at is trying to understand competitive wheat varieties. It's all very well saying variety X is more competitive than variety Y, but as we know, varieties come on and off the recommended list before you can almost blink. What we're trying to understand with this project is actually what makes a variety competitive, so we can say, as soon as a variety appears, is it going to be competitive against blackgrass or not? And the way it's working, it's a combination of these large containers and field trials, and it's looking at a number of different characteristics of varieties which may make them competitive against blackgrass. There's height at 370 thermal time, flag leaf length, final height, etc. And in containers, so these type of containers in the first year looked like all these things had an effect on blackgrass competitiveness. So whether they were short or long flag leaves, for instance, had an effect on blackgrass competitiveness. Unfortunately, the next year, fewer of those appeared to have an effect on blackgrass competitiveness. And in the field that year, there were fewer still. And in some cases, they did, they didn't, they did. It's not at all straightforward, unfortunately, determining which varieties are going to be competitive against blackgrass. It's a complicated slide. I just want to pick out one thing on here. This is container experiment in 2011 and blackgrass seed production. So if we look here, we've got Conqueror. In this situation, blackgrass seed production was about 20,000 seeds per square metre. With Santiago, it was about 30,000. So you think, well, Santiago and Conqueror, they're relatively similar species, relatively similar varieties. I think I've got some blackgrass. I think I'll go Conqueror. It seems to be a bit more competitive. Unfortunately, next year it was the other way around. Conqueror seed production was higher than it was for Santiago. It's just not very straightforward. Unfortunately, it's a poor girl doing a PhD project who's doing this. I think she's almost tearing her hair out because it's not at all straightforward. At the moment, we can't say for definite a certain variety is going to be more competitive than another variety. Hopefully, by the end of the project, we'll have something more definitive, but at the moment, we don't. Our Great White Hope, if you want to put it like that, is a project which we've put £280,000 into. It's a £2.8 million project, mostly funded by BBSSA. It's got a very long title, so we just tend to call it the Blackgrass Research Initiative. And these are their words, not mine. It's a multi-institute interdisciplinary collaboration to unravel the molecular mechanisms, genetics, ecology, evolution, and management of multiple herbicide resistance in blackgrass. Basically, what we're saying with this project is herbicides have failed, cultural options don't look very good, what else can we try? And it's looking at some very different sorts of things. This one I really like. I've called it resistance busting. I think I'm probably not the first person to call it that. But what people have found out with multiple herbicide resistance in blackgrass is it's really tied into this enzyme called glutathione transferase. And where you've got multiple herbicide resistance, this enzyme, production of this enzyme is cranked right up, and this switches on all sorts of genes through the plant, which helps it detoxify a range of herbicides. Interestingly, the same thing happens with cancer. If you're unfortunate enough to get cancer, they may give you chemotherapy drugs to treat it. Cancer has a nasty way of becoming resistant to that chemotherapy, and the way it does that is to crank up glutathione transferase production. It's the same mechanism. So what these researchers realised that there's a drug which is given to cancer patients to counteract this effect. I won't attempt to pronounce it, the name of it, but it blocks the effect of glutathione transferase. So they thought, well, what will happen if we apply that with a herbicide? And this is the results of that. So this is our wild type, our susceptible blackgrass. So if we this is just our control, nothing added. If we add this drug, it does absolutely nothing, helps it grow a bit. If we use a herbicide on a susceptible variety, susceptible blackgrass, obviously it kills it. If we add the herbicide and the drug, it kills it. Great. So what happens if we use the original resistant blackgrass? Well, our control, we don't apply anything. In this case, we apply the drug, nothing happens. If we apply the herbicide, nothing happens. But if we apply the herbicide and the drug together, it re-establishes the effectiveness of that herbicide. It's not 100%, but it's an awful lot better than this. So this is great. Problem with this stuff, it's extremely toxic. We're never ever going to be able to spray this stuff around the countryside. But it does offer us a potential route. If we could find something else which blocked this mechanism, it's a potential avenue that's being explored. Another thing this project is looking at is fingerprinting of multiple herbicide resistance. This is quite a complex slide. I'll try and explain it as best as I can. We've got 10 different populations of blackgrass collected from different parts of the country. And here we've got a number of genes. These different populations have different sorts of resistance. So we've got enhanced metabolism, ACC and ALS target site resistance. So the ones that have been highlighted all have the same type of resistance. They've got medium enhanced metabolism, and they've got both target site resistances. And the colours show effectively where the green, those genes are doing nothing. They're not producing active. Where they're very red, they're basically turned up to 11. So on all these populations where we've got similar sorts of resistance, we've got similar patterns of gene upregulation, as they call it. And if we look across this gene here, it seems to be upregulated in all the resistant populations. Why is that interesting? Well, it gives us the potential for a field test. It may be possible for you to go out, if you think you've got a resistance, you can crush up a little bit of blackgrass, add it to this field test, and it will tell you what sort of resistance you've got. So then you'll be able to target your herbicides precisely to what might work, what hopefully will work, rather than just spraying stuff and hoping it will work. I mean, we're quite a long way off this, but this is something this project is working on. They've got £2.8 million. They ought to get some way to hopefully finding an answer. Other things the project's looking at, it's been doing a blackgrass audit. You may say, oh no, not another one. But it's looking at populations across the main arable areas of the UK, England it's really focusing on actually, and looking at what sort of resistance we've got in different parts of the UK. Why is that interesting? Well, it's looking to develop a population structure across England. Why is that interesting? Well, we know that herbicide resistance can move around either in genes, via pollen. It can spontaneously arise in a field because of the way herbicides are being used, or it can be moved in seed. If you're transporting straw from Cambridgeshire to Wales, are you carrying herbicide-resistant blackgrass seeds with it? If we know how, and what we can do if we look at the genetic variation in these populations, if we find a population in Cambridgeshire, it's exactly the same genetic structure as one in Wales, we can be pretty sure that it's got there on the back of a lorry. It certainly hasn't got there by pollen, and it's almost certainly, well, the chance of those two arising spontaneously exactly the same on opposite sides of the country are virtually nil. So what that will tell us is how resistance is spreading around the country and how we might be able to stop it spreading anymore. And not just for blackgrass, we've already talked about resistant ryegrass, resistant oats. If we can understand how blackgrass is moving around, it may enable us to stop these other resistant weeds in their tracks before they become a big problem. And it's also looking at what the environmental and economic impact. As I said, we haven't always looked at that in the past, and this project is going to look at, if we do go with some of these alternative ways of controlling blackgrass, what are the implications of those? Publications. We've got a weed management guide. That's updated every 4 years or so, every 3 years, depending on new information. And then we have our usual range of topic sheets which come out on a fairly regular basis, updated on a fairly regular basis, and they're available either in hard copy or on the website, of course. If any of you are sitting out there thinking that what we really need is herbicide-tolerant crops, no. They won't work either, because all will happen is we will get resistance to those. This is data from DuPont in the States. Of course, glyphosate-resistant crops were first introduced in 1996, and by 2002 we already had glyphosate-resistant weeds in the main corn-growing part of the US. If you move forward to 2012, this is number of species, and my US geography isn't brilliant, but I think that might be Alabama. They had 8 species of weed which were glyphosate resistant by 2012. And right through the main corn belt of the US, they've got multiple species that are resistant to GMO, to glyphosate. So herbicide-tolerant crops aren't the answer. We'll just get there with herbicide resistant to them in the end. Thank you.